Okay, let's start off with a 2024 set for acid, bases, and salts. Question 1 says carbon is found in inorganic compounds such as carbonates. Write the equation for the reaction between magnesium carbonate and dilute hydrochloric acid. I think it's more than AS level, it's O level IGCSE equations. We've already done this. Magnesium carbonate is MgCO3, and those who have forgotten O level as an IGCSE, although I have revised everything, magnesium has a charge of 2 plus and carbonate is 2 minus, and therefore the charge is balanced out, and therefore for one magnesium ion, one carbonate ion is needed, or you can say MgCO3 is therefore the formula for it, right? Reacts with HCl, gives me what? It would give me MgCl2, magnesium chloride, and the hydrogen in the acid and the O's right here will give me H2O, and carbon dioxide will also form. So you'll have MgCl2 plus CO2, carbon dioxide, and plus H2O. It doesn't matter the order in which you write it. You can write H2O first, carbon dioxide first. It really doesn't matter. And now if you were to balance it, you see you have one chlorine on the left hand side but two on the right. I'm just going to plug in a 2 and it's all going to be balanced. Everything is balanced. You can check out the equation. All the oxygens, 3 oxygens on the right, 3 on the left, carbon 1 carbon, everything is balanced. Done. Now it says describe the thermal stability of carbonates down group 2. We've already done this in chapter 4, but we'll describe it for him here. Please don't just say it increases. No, don't say it increases. This is not description. Description is like write a proper phrase or a sentence in it, right? So say, hey, the thermal stability of group 2 carbonates increases down the group, and we know why it increases, although it's not a part of your course. It has to do with polarizability or polarization, distortion of the ions, right? The charge densities and all of that good stuff. It's not a part of your course, but I gave you a tinge idea in the live classes. You learned this in A2 basically, right? Now it says ammonium carbonate undergoes an acid-base reaction with NaOH aqueous. Explain this statement. Now you know that ammonium salts are slightly acidic, right? So if you have ammonium carbonate, that's ammonium carbonate right here, NH4 whole twice CO3, plus what does it undergo the reaction with strong bases. So explain this statement. Explaining this statement is to talk about the acid and base nature of ammonium ion and the basic nature of the hydroxide ion. So I'll tell the examiner, hey, I'm going to explain it to you. Basically, examiner, the ammonium ion is a proton donor, and that's why this reaction takes place. It's a proton donor. Whereas the OH minus ion, because effectively the reaction that is taking place is between the ammonium ion and the OH minus ion. The ammonium ion is basically a proton donor, right? And what it does is it donates a proton right here, and OH minus accepts the proton and forms H2O. So we say ammonium ion is a proton donor and hydroxide ion is a proton acceptor. That's all the examiner required, and hence acid-base reaction takes place. That's it. Done and dusted. Next. A common test for nitrates is the reaction with NaOH and aluminum, and we also warm it. Remember in O levels and IGCSE you learned this, that it's NaOH plus aluminum foil. You wrap it in aluminum foil and you warm it, and this is actually the reaction that you were never taught in O levels and IGCSE. And it says NH3 is a basic gas. Describe how it's able to act as a base. It's pretty simple. It's a proton, or let's properly write it in English. NH3 is a proton acceptor or donor. So bases are protons acceptors. So it's a proton acceptor. That's why it's able to act as others. Let's go next. That's it. 2024 set is over for acid, base, and salts. Moving on to the next set.